Hello friends, welcome to lecture number 13 of Electricity and Magnetism. So today we are going to discuss about quality factor of LCR circuit, and I have provided the links of previous lectures in the description box. So if you haven't watched yet, you may go through them. So now let's start our topic. So before we start, please subscribe the channel if you are new to my channel. Also share with your friends, and if you think these videos are helpful, please hit the thumbs up button. Also hit the bell icon so that you get notified when new video will be uploaded. Okay, so now let's start. Before we discuss about quality factor, let me draw this graph here, current versus frequency graph for LCR circuit. So at this frequency here, you see here we get the maximum current at this frequency. This is resonant frequency, suppose omega r. So here we get the maximum current I naught. So just wait. So let me write this one here. Okay, so here we got I naught is equal to E naught by Z, which is impedance, and at resonant frequency Z will be equal to the resistance R, that is E naught by R. So let me tell you how. So here you see at resonant frequency. So before that, let me write the definition of the quality factor. So here you see the quality factor is defined as the ratio. So let me write it properly. Ratio of resonant frequency, that is omega r, where the current is maximum, I naught is maximum here, to the difference in frequencies on both sides of the resonant frequency, at which the current falls to 1 by root 2 times of maximum current. So here on the both side of this resonant frequency, we will get two frequencies, suppose omega 1 and omega 2, at which the current becomes 1 by root 2 times of I naught, right? So here you see, if an alternating EMF E naught sin omega t is applied to an LCR circuit, and then oscillations occurs, and the oscillating current is given by I naught is equal to E naught by Z. So where Z is impedance, so let me go to the next slide. So where Z is impedance, which is equal to given by root over R square plus omega L minus 1 by omega C whole square. So where omega L is inductive reactance, that is XL, inductive reactance, and 1 by omega C is capacitive reactance, that is XC. So hope you know these things. So now you see at resonant frequency, omega R, the current is maximum, and XL is equal to XC. So we know XL is omega L, and XC is 1 by omega C. So their difference will be 0, right? as these two are equal. So hope you have understood, and hence Z will be equal to R square plus 0, that is R square, which is R. So maximum current I naught will be E naught by R, right, at resonant. Now you see, if you see the diagram, if you observe the diagram, let me go to the previous slide. So here you see, at these two frequencies, omega 1 and omega 2, so the current is 1 by root 2 times of I naught. That means 1 by root 2 times of the maximum current. Okay, so here you see, so here this is at resonant frequency, that is when XL is equal to XC, right? So at omega 1, so just wait, here you see, so let me write here, you see, as I have written here, I naught is equal to, when it is maximum, is equal to E naught by R. So at this frequency omega 1, this current falls to 1 by root 2 times of its maximum value. Maximum value is E naught by R, so let me write 1 by root 2 of E naught by R. So let me write that way. So at omega 1 and omega 2, so value of I naught will be 1 by root 2 of its maximum value, that is E naught by R, right? So here we can say that at resonant frequency, Z is equal to R, and here at omega 1 and omega 2, Z is equal to root 2 into R, right? So hope you have understood this. So now let me go to the next slide. Now you see that I have already got at I have already shown you that at omega 1 and omega 2, Z is equal to root 2 times of R in the previous slide. Here you see, so that's why we can say Z is equal to, we know that Z is equal to R square plus omega L minus 1 by omega C whole square, that is equal to root 2 times of R, and squaring both sides, we're gonna get R square plus omega L minus 1 by omega C whole square to R square, and this implies R square is equal to omega L minus 1 by omega C whole square, and R will be equal to plus minus root over, so roots gonna cancel this power 2, so that's why omega L minus 1 by omega C, that's what we get. So now you see here, so here we have considered that you see the diagram, omega 2 is greater than omega 1. So here let me draw a line here. If omega 2 is greater than omega 1, right, then we can write, as omega 1 is less, from this relation we can write omega 1 L minus 1 by omega 1 C, that's gonna be equal to minus R, right? So you can write this way, this is equal to plus minus R, right? So for the lesser frequency it's going to be minus R, and if omega 2 is greater, so that's why omega 2 L minus 1 by omega 2 C, that's going to be plus R. So this is suppose equation number 1, and this is suppose equation number 2, right? If you add these two equations, adding 1 and 2, what we're going to get, this minus R and plus R are going to be cancel each other. So on the right hand side, left hand side, we're going to get omega 1 plus omega 2 L will be common, and then similarly 1 by C will be common. Within bracket we're going to get 1 by omega 1 plus 1 by omega 2 on taking minus common. So on the right hand side it's going to be 0, and this simplifying this, what we're going to get, omega 1 plus omega 2 into L on the other side. If you take this term to other side and simplify 1 by C, here omega 1 plus omega 2, omega 1 into omega 2, that's what you're going to get, right? So here omega 1 plus 2, omega 1 plus 2 gone, so we have got L is equal to 1 by C, 1 by omega 1 omega 2. That's what we have got. So this implies that omega 1 into omega 2 is equal to, right, what we can write, 1 by LC. That is what we can write. Okay, so hope you have understood this point. Now you see, if you subtract these two equations, then what are you going to get, right? Let us subtract 1 from 2. So let me go to the next slide. Let me rewrite this equation. So on the next slide, so let me copy the two equations. If you subtract these two equations, if you subtract 1 from 2, so that means 2 minus 1, so then what are you going to get? So in that case you will get this minus this, then L will be common, so you will get omega 2 minus omega 1, right? And here this term minus this term, then if you take 1 by C is common, then within bracket what you will get, 1 by omega 2 minus 1 by omega 1, that's what you will get, right? And on the right hand side, R minus minus R, that's going to be R plus R, so twice R. So hope you have understood this. Now you can see that actually what happens when you subtract 1 from 2, so this should be positive and this should be negative, right? So hope it is clear now. So now you can see that's what we have got. So here we have taken LCM, here we have got minus omega 1 plus omega 2 by omega 2 omega 1, which can be written in this way. So hope you have understood these things, very simple, right? So now you see what we can do, we can take this part common, right? So on taking that common, we will get, so here we have taken these two terms common, and doing so we have got this result. Now you see we have already got that omega 1 into omega 2 is equal to, so here you see in this slide, omega 1 is equal to omega 2, sorry, omega 1 into omega 2 is equal to 1 by LC. This is suppose equation number 3. Let me use this equation here. So then what you will get, 1 by omega 2 minus omega 1 L plus 1 by C into 1 by omega 2, omega 1 into 1 by omega 2, that is equal to 1 by LC. So 1 by omega 2 omega 1 omega 2 will gonna give you LC, right? LC, right? So hope you have understood this 2R. So what we have done here using equation number 3. So here we have used this equation. So sorry, we have used this equation number 3. Omega 1 omega 2 is equal to 1 by LC. So instead of 1 by omega 1 and omega 2, we can write LC, right? That is what we have done here. So here C cancels. So what we're gonna get, let me go to the next slide. So now we will get that omega 2 minus omega 1 into L plus L is equal to twice R. That's gonna be equal to twice L into omega 2 minus omega 1 is equal to twice R. Here 2 cancels, right? And omega 2 minus omega 1 is equal to R by L. That's what we will get. and this expression is called bandwidth. This is called bandwidth, right? This is expression for bandwidth. And by the definition of quality factor, right, according to the definition of quality factor, by definition, quality factor, so quality factor in LCR circuit, Q is equal to the resonant frequency omega r by bandwidth. That means the difference, between the frequencies omega 2 minus omega 1, where the value of current becomes 1 by root 2 times of the maximum value of current, right? So this is nothing but quality factor in LCR circuit. So hope you have understood these things. So if you like the video, then share with your friend, hit the thumbs up button. If you are new to my channel, subscribe the channel, and also hit the bell icon so that you get notified when new video will be uploaded, and stay connected. See you in the next video. Bye.